Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the question on electrolysis on the board. And the question is as follows. An electric current of 100 amperes is passed through a molten liquid of molten sodium chloride for 5 hours. Calculate the volume of chlorine gas liberated at the electrodes at STP. Now, to solve this particular question, we need to, first of all, ask ourselves, where will chlorine gas be liberated? Is it at the anode or at the cathode? Chlorine gas is going to be liberated at the anode. Now, for us to proceed to solve this question, we need to be able to write the equation for the reaction at the anode. And that equation is 2 chloride ions will lose 2 electrons to give us chlorine gas. So this is the equation for the reaction at the anode. Now look at this equation. You can see that the number of moles of chlorine gas here is 1 mole. And the number of moles of electrons is 2. So this is the same thing as 2 times 96,500 coulomb. And the reason is because the quantity of charge in 1 mole of an electron is 96,500. Therefore, the quantity of charge in 2 moles of electrons will be 2 times 96,500. The question is telling us to find the volume of chlorine gas that is liberated at the electrode at standard temperature and pressure. Now, we need to remember that 1 mole of any gas at standard temperature and pressure has a volume of 22.4 dm³. So, what this means is that we can infer from this equation that 2 times 96,500 coulomb liberates 22.4 dm³ of chlorine gas at STP. That is the conclusion we can draw from the equation at the anode, which is on the board. Now, the question is telling us to find the volume of chlorine gas liberated at STP if an electric current of 100 amperes is passed for 5 hours. Now, we need to recall that quantity of charge is equal to current times time. Now, current, according to this question, is 100 amperes, and time is 5 hours, which should be in seconds. So this is 5 times 60 times 60. So it means that the quantity of charge here is going to be 100 times 5 times 60 times 60. So this is the quantity of charge. So what this means is that the question is telling us to find the volume of chlorine gas that is going to be liberated at standard temperature and pressure by this quantity of electric charge. So we're going to say if 100 times 5 times 60 times 60 coulomb liberates X dm³ of chlorine gas at STP, then we can cross multiply. So that is going to be X times 2 times 96,500 is going to be equal to 22.4 times 100 times 5 times 60 times 60. And X is going to be 22.4 times 100 times 5 times 60 times 60 divided by 2 times 96,500. And when this is solved, and this is simplified, you're going to get 208.9 dm³. So what this means is that the volume of chlorine gas that is going to be liberated at STP when a current of 100 amperes is passed for 5 hours is going to be 208.9 PMQ. So I want to believe that the explanation of the solution to this question is clear. Thank you very much for watching, and see you in the next one.